This is 6.1.3. We are now going to explain the concept time versus frequency representation. Well, time representation is easy because x of n, the sequence, is with respect to n. N is the sample index, and of course n is time. Each sample is separated by the sampling period. So time representation shows us what we see of the function x across time. What about frequency representation? Well, we say that we convert, let's say, this periodic signal to ck and x of omega, and for aperiodic signal we convert it only to x of omega. So why do we think of this as the frequency representation of x? Well, the idea is this: ck's and x of omega is showing x of n as a function of frequency. Here the frequency is digital frequency, how many radian per sample. Omega is fine. Omega, you will say that it is really radian per sample. What about ck? What is the index k? Well, the index k is actually showing the frequency at 2 pi divided by n times k. So k equals to 0 means 2 pi divided by n times 0 radian per sample. So that's the relationship of k to omega. Omega is called the digital angular frequency. The digital because we are in discrete time, so it's with respect to sample. The angular frequency is from 2 pi. I mean, how fast we are rotating. So it's 2 pi. How many samples? So how many radians per sample? So please remember this term, digital angular frequency. Right. So now let us see the relationship of k to omega, radian per sample. So if we have k equals 0, 1, 2, 3 up to, in this previous example of n equals to 8, so what we see is that we'll label C0, C1, and in fact we're only interested in C0 up to Cn minus 1, okay, for the magnitude and the phase. What about C8 to C, so on and so forth, and what about C minus 1 to C minus 8? Later on you see it's 2 pi periodic, so C8 is the same value as C0. C9 is the same value as C1. Let us see the mapping of k to omega. Remember, once we have capital N, the map is simply this: omega equals to 2 pi divided by the n times k. Okay, so this maps c k for n equals 8 to 0 to 2 pi in this way. So every jump, C0 to C1, C1 to C2, in this example, shows that it's 2 pi divided by 8, means pi over 4 radian per sample for different case. Now, I explained that the ck's and x omega are 2 pi periodic. Why is this so? Why am I only interested in 0 to 2 pi? What happened to 2 pi to 4 pi, 4 pi to 6 pi, or minus 2 pi to 0? Well, let k be 0 to 7. What happened to k equals 8 to 15? Well, if you go and plot for k equals to minus 7 and compare to 1 and compare to 9, what will happen is that you will realize that when you put it into ej omega n, it is the same. And hence, the coefficients you calculate would be the same. So whether you're calculating at k equals to minus 7 or k equals to 1 or k equals to 9, the found value of ck would be the same because ej omega n is the same.